We now get to take a little break from functions and talk about volumes of cones and spheres. I know it seems like it's really off topic, and it kind of is, but because functions is such a small unit, this is a good place for us to fit in the fact that you need to know the formula for how to find the volume of a cone and a sphere. So let's go ahead and start with some of the basics, just get our mind remembering about how to find an area and volume. So let's start with finding the area of a rectangle. So maybe this rectangle right here, that's 4 by 9. Now, if we want to find area, because area is two-dimensional, you need to multiply two dimensions together. So one of the dimensions is 4 and the other one is 9. So you might remember from super long time ago in school that the area of a rectangle is going to be your length times your width. And with length and width, a lot of people like to put the longer one as length and the shorter one as width, but it actually really doesn't matter. So the formula we could write down as L times W. So in this case, if we wanted to actually find the area, we could put in 9 for our length, 4 for our width. Remember, it doesn't matter if you switch those. And so the area in this case would be 36 centimeters squared. And they're squared because this is a two-dimensional measurement. Let's now take a look at how to find the volume of a rectangular prism. With a rectangular prism, we have to have 3 dimensions because volume is a 3-dimensional measurement. So the way that you find volume is you essentially need to take the base, just like the top of whatever it is that you're measuring, and then multiply it by the height, because you're essentially saying, I have this sheet of paper, and then there's this many layers of that sheet of paper to make up all of this. So what you have is you have your base times your height, and since the base in this case is a rectangle, well then the base is going to be your length times width. So the whole entire formula for this would be length times width times height. So in this case, we need to do 3 times 9 times 5. And realistically, it doesn't matter which order you have them in. You can define this top one as the base, you can define this side one as the base, you can define this front area as the base, and then just multiply by the other dimension. So in this case, we need to do 3 times 9, which is 27, and then times 5. So we'll need to use a calculator for that. And when we put it into our calculator, 27 times 5, we get that it equals 135. In this case, we have inches that are cubed. And it's cubes because it's a 3-dimensional measurement. So now let's move on to finding the volume of a cylinder. Now with the volume of a cylinder, it's extremely similar where we need to find the area of the base and then multiply it by the height. Now with a cylinder, the area of your base is a circle. So we need to remind ourselves how to find the area of a circle. So with the area of a circle, it's always going to be pi times your radius squared. So the radius, if you remember, is half of the diameter, where the diameter is a line that goes straight across the circle going through the center. So in this case, they actually give us the radius is 4. So if we want to find the area of that circle, we're going to put it into the formula of pi times our radius squared, which our radius will be 4 squared. And I know I keep kind of changing the way I write my pi, but there's a couple different ways to write pi, and that's totally okay the way that you want to write it. So in this case, we can think of it either as 16 times pi, when some of your high school teachers will be okay with you leaving it like that, or we can just throw it into our calculator and find out what 16 times pi is. And I got that it's about 50.27, and so it's meters squared because this is area. Now that we remember how to find the area of a circle, let's actually look at how to find the volume of a cylinder. So for volume of a cylinder, it's going to be your base times your height, whereas your base is that area of the circle. So altogether, your actual formula for the volume of a cylinder is going to be the area of a circle, so pi radius squared times your height. So this is going to be the formula you're going to use for the volume of a cylinder. So now we can just take the numbers and put them in. So in this case, our radius is 5. So we have pi times 5 squared times our height, which is 7. And then we can just put these into our calculator and find out. So we put in pi times 25, because that's 5 squared, then times 7, and I'm getting that it's 549.78. If I calculated something wrong, please let me know. Now we always want to put units on this, so this sign tells us it's inches, and it's cubed because it's a three-dimensional measurement. Sometimes if they don't give you a unit to use, you can just say unit. So if they didn't say that it's inches, we could say 549.78 units cubed. So you can always put that in if you don't know what the actual units are. Now I know that some of you are going to be confused. Why are we talking about rectangular prisms and cylinders if the lesson is about cones and spheres? Well, you need to understand those in order to figure out the formulas for cones and spheres. So here we have a cone. So it's just like an upside down ice cream cone. And you can actually think about cones the other way, like an ice cream cone, but technically in math you see it kind of in this shape, but it can be actually on its side or any other way. It's still the same shape. So here we have a cone. Now, the base of the cone is a circle. The height of this cone is 9, but if we do base times height, that's not really taking into effect the fact that it's slanted on the sides. So if we have a cone and we have this base of a circle and this height, we have to kind of compare it to the cylinder that fits around it. So if we have a cylinder that can essentially fit on top of it that has the exact same dimensions, the same base and the same height, we have to essentially figure out how much of the volume of the cylinder is the cone taking up. So that way all we have to do is find the volume of the cylinder and essentially just take it down to this size. So if you want to take a guess, think about like how much do you think that would be? So if I think about having a cylinder around this cone just fitting into that cylinder, and I apologize that's about drawing, how much of that space does the cone take up? Well, the cone actually ends up taking up 1/3 of the cylinder, which is good for us to know because all we have to do is find the volume of the cylinder and then multiply it by 1/3. So if you remember from before, the area for the cylinder was that base times height, but the base is a circle. So it was pi r squared times height. Then all we have to do is multiply it by 1/3. So this is going to be your formula for a cone, 1/3 of pi times your radius squared times your height. So let's actually try this one. 1/3 and pi, of course, stay the same. Your radius is 5, so that becomes squared, and your height is 9. So all we have to do is crunch these numbers, and then we can figure out what the volume is going to be. So I'm going to start by putting in pi, then I'm going to times it by 25, because that's what 5 squared is. Then I'm going to times it by 9. Then, in order to account for 1/3, instead of multiplying by 1/3, which is hard to put in your calculator, I'm instead going to divide by 3, which is the same thing. So I'm going to divide by 3, and I get 235.62, and we have inches cubed. If I did my calculation wrong, please let me know. So let's take a look at another example. So here it asks us to find the volume of a cone that has a radius of 2 and a height of 7. I always like starting with drawing a picture. So we can start with drawing a circle for the base, and then it just kind of comes up to a cone. So our radius was 2, and our height, that's not straight, is 7. So that's what we're going to be finding the volume of. So remember, the formula is 1/3 pi radius squared times the height. I'm actually not going to walk you through this one. I want you to try it on your own. So you have the formula and you have the numbers. Plug them in and crunch those numbers. If you have any questions, you can ask me in class or comment in the comment section. So now let's look at spheres. Spheres are actually similar to cones in the fact that we can find their volume by thinking about the cylinder that fits around them. So if I have a sphere, I have to think about how much space of the cylinder it takes up. So in this case, a sphere actually takes up 2/3 of the cylinder that has the same dimensions. So just like with the cone, we essentially can find the volume of the sphere by finding the volume of the cylinder that fits around it and then just multiplying by 1/3. So I'm essentially thinking about this as having the same dimensions as a cylinder that fits around it, but then I'm going to multiply it by 2/3. So it's going to be 2/3 of that cylinder formula. So remember, the cylinder formula is pi times radius squared times the height. Now you can just remember this formula if you want, but there's actually a more simplified formula, and it's the one that you're always going to see if you ever look up volume of a sphere. Now take a look at this formula. For a sphere, the height is something interesting because the height's going to be the same as the width. The height for a sphere is the diameter. And the diameter equals 2 times the radius because it's twice as much. So we can essentially replace this height by 2 times radius. That also seems complicated and a little redundant. We can combine some of those terms, so let's go ahead and do that. We can combine 2 and 2/3. Well, if we multiply 2 and 2/3, that's 4 1/3. And if we combined r squared and r, well, there's 3 r's. And of course, we still have our pi. So this right here is actually the formula you're going to use. I'll rewrite it so it's nice and clear. 4/3 pi radius cubed is the formula you're going to want to use. If you want to remember it from this way, you of course can, but you have to think about the fact that you're including the fact that the height is the diameter and all this stuff. So if you ever forget and you have to look it up, this is the one you're going to use. 4/3 pi times the radius cubed. Let's actually find the volume of this sphere. So my formula was 4/30 pi. Then I need to put in my radius, which is 9, which is going to be cubed. So all I have to do is crunch those numbers. So I'm going to start by putting in 4 times pi times, I don't know 9 cubed off the top of my head, so I'm going to put in times 9 times 9 times 9, because that's what 9 cubed is. But then I still need to divide by 3. Divide by 3. So, and you can let me know if I did something wrong, I'm getting that it's 3,053.63, and these are centimeters cubed. Please let me know if I did a calculation wrong. So now let's look at another example. So here it's asking us to find the volume of a sphere with a radius of 3. So I like starting with a picture. And we have a radius of 3. So there's my sphere. It's a odd looking sphere, but we'll call it a sphere. And I need to remember my formula. Well, we just found out that the formula was 4/3 times pi times the radius cubed. So if we're going to calculate this, really all we need to do is take that 3 and put it in for radius. And I'm going to let you finish this one up because you should be able to do this. If you have any questions on this, you can of course ask me in class or comment in the comment section. And that's it for this lesson.